Hi and welcome. So, today we're gonna do this question, which is pretty much background knowledge in preparation for Year 12 methods. The question is from the book Maths Studies. So, let's have a look what we have to do here. So the question says that infinitely many cylinders may be inscribed within a right circular cone of radius 5 centimeters and height 10 centimeters. If the cylinder has radius r centimeters and height h centimeters, express the volume V of the cylinder as a function of A, R, and as a function of H in part B. So you may think now, like, why do I need this? So sometimes when you have to, when you're looking at optimization questions, so you either you want to optimize obviously the question. Sometimes optimization means, to make something bigger or smaller, maximizing or minimizing. So looking at this question, sometimes we do want to have the optimum radius for the benefit of this question, or we are after the height. So therefore we want to have questions in terms, or the formula in terms of R and or in terms of H. So if you're still not sure what I'm talking about, just stay there and I will try to explain. So let's have a look. So the first thing, what I'm going to do on this side, I will write the formula, volume formula for, so what do we need? Cylinder, okay? Cylinder, that equal side is going to bother me. So cylinder equal, volume of the cylinder is equal to pi r squared times height. So how do we find the volume? Its base, in this case, of the cylinder is circle, the base, the area of the base, and then times height. Okay, so pretty much this is what we have here. I'm gonna get rid of this because I'm gonna need that picture later. Now the next step, it would be to start some labeling. Have a look what has been given and to start labeling. So what does it say here? Cylinder cone has a radius of 5 and height of 10. So cone has a radius of, so cone. So with the cone, this is the cone, okay, or this is cone, and now I'm gonna get rid of that color again, so but that's the coin. And I'm gonna do some labeling here. Radius is 5, so radius of this cone is 5. So this is 5, and the height of this cone is 10. So I'm gonna put here 10, 10, 10, 10. Okay, so that's what has been given. Now, we do have other two variables that are given. So the cylinder has a radius of r. So this is a cylinder here, and I will use this. This is cylinder. Okay, maybe use. Okay, this is the radius. So what I'm gonna do here, I'm gonna go like, this is the radius of the cylinder. And what else? And the height of the cylinder. So I'm gonna have here, okay, so this is the height of the cylinder, okay. And yes, now what we have to do is to find the volume of the cylinder as a function of R and then as a function of H. So now we're looking here, the volume, it's pi r squared times H. So and it's like, okay, so we have R and we have H, but the question is asking to have either in R's or in H. So which means one formula is not going to have R and another formula is not going to have H. So it's going to be in terms of R or in terms of H. So, which means we have to find some values for R and H, for the radius and the height. So what I'm going to do next, I'm going to actually draw a picture here on this side. So this is, okay, so this is the line, and this is going to be 10. This is the height of the cone. Okay, you know what? I'm going to do the same side because maybe if I go like this, maybe you're going to be confused what I'm doing. So what I'm going to do, I'm going to actually take out, okay, do like this, still, okay, there you go, gone. Now, I'm going to draw, what do we have here? Yeah, I can still go with that one. This is the line. And this is, okay, oopsies, I don't want to delete. Okay, so, and we said here on the side that this is the 10. Pretty much, you know, if I draw on this side, that's the same thing, isn't it? Okay, so that's 10. So this is this line, and this line, and this line, okay? So that's big triangle. Now, what I'm going to do, I'm going to label another triangle here from there, that's, yeah, and this one here, and that one there. So, and you can see that that one is inside the bigger triangle. Pretty much, I'm just going to approximately draw a line here, okay? And I'm going to label, this is H, okay? So which means I can just put here, okay? So this is H. And then this length here, this one here, I don't know yet because I already forgot the numbers that have been given. But I'm going to check the question and look, okay, it says the radius of the cone is 5, which means this is 5, this is 5, all of it, okay? So all this length, radius of the cone is 5. Then I have here the radius of the cylinder. So this is the radius of the cylinder. And if this is R, and this is 5, then this length here has to be what? Yes, you're right. Has to be 5, take away R. Okay, so we have some labeling here. I don't know if you do remember similar triangles, so but this is what we're gonna do. So when you have similar triangles, so I'm quite positive you remember that the ratio of corresponding sides is equal, corresponding sides. So we have to be careful. So if I'm gonna go with this side first, like this side, so that's my 10 over the ratio corresponding. So this is another one, okay? So H is equal to the ratio of the other corresponding side. Now we have to be careful. If I started in my numerator, this is number 10, it's from the big triangle, then I have on the other side to have, the value from, you know, the big triangle as well. So which means this one, 5, okay? So now we're gonna have 5 here, and then over the ratio divided by, so this one here, okay, which is 5, take away R. So if I took this big triangle here, okay, so big one here. So they're right angle triangle, okay? So this is 10, this is 5, this is now smaller one. So this is H, this is 5, take away R. So it's similar triangles. Similar triangles, in this case, this one, they have the same angle, okay? So they share this angle, and they have other angle that is the same, which is 90 degrees angle. So, but I'm quite positive you have done this before. So now, if I want to have H by itself in this case, so the easiest way, in my opinion, is the like cross multiplication. I'm gonna like sort of undo this. Yep. So highlight, cross multiplication, but you can use any other methods that you want. You can multiply both sides by whatever. I'm not gonna, confuse you, but in my opinion, the easiest one. So we're gonna have 5 times H, so cross multiplication is equal to 10 times 5 take away R. So let's expand this. It's 50 take away 10 R. So, and if I want H by itself, divide everything by 5, and it's going to be 10, take away 2R. So this is your H, okay? Now, to find the volume in terms of H, so we're going to have pi in terms of R, this case, pi R squared. And now, when we see this H, in this case here, okay, instead of H, we're gonna replace, oopsies, I deleted it. Silly me. So we're gonna replace this H in here. Okay, I'm just gonna write it here, and then I'm gonna get times H. But we don't want H, we want to get rid of it. So instead of this H, we're gonna substitute this bit there, okay? So let's now delete it, go, and then it is, we have to have brackets because it does have more than one term. Now, you can actually expand this, but I think there's no need. So don't forget just units. In this case, centimeters, and volume is to the power of 3. So this is volume formula in terms of R, in terms of radius. Now, if you do want to do in terms of H, yep, so we had here H equal to, now what from here, from this step there, so we're gonna do, first I'm gonna rewrite that step. Okay, so it's like 5H equals 50, take away 10R. Now we want R by itself. So 10R on this side. Can you see how it actually becomes positive? This negative becomes positive, this positive becomes negative. Again, that's, assume knowledge from many years ago. And then we want R by itself divide by 10. So 50 divided by 10 divided by 10 is 1. 50 divided by 10 is 5. Negative 5 divided by 10 is negative half H. So, or this is the same thing, okay? That's the same thing. Now we have that R. Now let's have a look at the volume. Volume is equal to pi. Now R, instead of R, we're going to have 5 take away H to the power of 2, H divided by 2, and then everything to the power of 2, and then times H, okay? So, let me just like, so this is like R, okay? But my 5s, they look like S, honestly. And even when I am trying to change, it still look like S. Yeah, so this would be the volume. Don't forget the units. So I don't have units here, but units, in this case, centimeters to the power of 3. So that would be all for this question. Okay, thank you for watching, and I talk to you soon. Bye.